Okay, we'll have a look at simple titration calculations. These are ones where you're just given the concentration of one of the solutions, like a standard solution, and you don't know the concentration of the other. I'm not doing one here that involves making up a standard solution or any other parts that complicated titration calculations in the first instance. I'll do another one which will have a little bit more detail about the more complicated ones later. So for an example, let's have calculate the concentration of sulfuric acid given that 23.50 centimeters cubed was neutralized by 25.00 centimeters cubed of sodium hydroxide of concentration 1.0 moles per decimeter cube. So in this particular calculation, you've got a standard solution of sodium hydroxide, which you know the concentration is 1.0 moles per decimeter cubed. You've used 25.00 centimeters cubed of it. Chances are that that's perhaps measured out in the pipette. And the other reagent, which is sulfuric acid, all you know is the volume, which is 23.50 centimeters cubed. So the first thing you would do is you would write the acid-base equation, which would be H2SO4 plus 2NaOH makes Na2SO4 plus 2H2O. And from this we can work out the balancing. So we've got 1 mole of sulfuric acid reacting with 2 moles of sodium hydroxide. So we often hear people saying this is a 1:2 ratio or a 2:1 ratio. They will also occasionally you'll hear somebody saying that the sulfuric acid is diprotic because it's got 2 hydrogen ions per molecule. Step 2. Work out which of your chemicals you know the most information about. Generally, I write a little tally chart like this, so I've got volume of acid and concentration of acid, volume of alkali, concentration of alkali, and I fill it in from the question just to make sure I've got the right information and to find out which one I know the most about. So the volume acid in this case is 23.50 centimeters cubed. That's probably come from the burette readings. And the volume of alkali 25.00 centimeters cubed, and the concentration 1.0 moles per decimeter cubed. Here we've been asked for the concentration of the acid, so that is obviously not known. Looking at this, the alkali is the one which I should start with because I know the most about that. So I know the volume and the concentration. From then you should start working from the one you know the most about. So in this case it's sodium hydroxide. Equation to use is calculate the amount of moles, which equals concentration times volume divided by 1,000. In this case, because I've got divided by 1,000 there already, we can use the volume in cubic centimeters. This is most convenient because normally when we're doing a titration we're working in centimeters cubed. Obviously then in this case the amount in moles of sodium hydroxide is C times V over 1,000. So that's 25.00 times 1.0 divided by 1,000, which is 0.025 moles. We could use the ratio from the equation to work out the amount of the other chemical, which in this case is sulfuric acid. So we already know that 1 mole of sulfuric acid would react with 2 moles of sodium hydroxide, so we say it's a 1:2 ratio. This tells us that we need half as many moles of the H2SO4 to the NaOH. How I tend to do that is in the equation I would put my thumb over the one I know the most about. So in this case I would have put my thumb over the NaOH and then looked at the other reagent and realised I'm going to need less of it, so I would then divide by 2. Because just put my thumb over the one that I know the most about, I can see that there's twice as much sodium hydroxide as sulfuric acid. Lots of people have a problem of whether to divide by, in this case, the 2 or multiply by the 2. So that's always worked for me. So in this case, we know we have 0.025 moles of the sodium hydroxide. It will therefore react with half as much of the sulfuric acid, so that would be 0.0125 moles. Now you have the amount in moles for the sulfuric acid. We can rearrange the equation we used earlier, which is amount in moles is C times V over 1,000. Don't forget when you're working out the concentration here, the amount in moles is for the sulfuric acid. Times it by 1,000, and the volume has got to be in cubic centimeters. Again, make sure you use the right volume. Most of the time these volumes will be different, so you can just look back at the first part of the equation and just check that out. Once you've got the concentrations, that'll be in moles per decimeter cubed. Usually do it to 3 significant figures and put it in standard form.